Okay, thank you. So welcome everybody. I will have some slides on the demo. The goal is to show that we can run a database on Kubernetes, fully cloud native, which means scaling out as we want. I will demo everything from the beginning, and then before going to the slides and even introduce myself, I will start to create the cluster because it takes a few minutes. The most difficult if you want to use Kubernetes on the Oracle Cloud is to find it. So once you found it, everything is easy. In the Oracle Cloud, you have to go to developer services. And there you can see Kubernetes cluster. And then everything is really easy. You just create a cluster, and for lab, the quick create is perfect. It creates the network, it creates the control plane, everything. And this is what I will do here with mostly everything as default. I will put all nodes in the public network because it's a lab. Of course, don't do that with your production data. I just use 4 OCPUs and 3 nodes to start. We will see that we will scale out, and that's mostly what I will change. I don't need to SSH to the server. So this quickly, the nice thing with the Oracle Cloud, if you want to recreate it later, you can save it as a stack and then use Terraform to destroy and create it again. I need it only once here for this demo, and then I clicked on create cluster. It will create all the resources and also the servers in behind. It takes a few minutes, and then we will come back to it later. I'm Franck Pachot. I'm developer advocate at Yugabyte after working almost 20 years with the Oracle database as a consultant. I'm not a consultant anymore. I'm still using, helping users, but for free. And on a database also that is free because Yugabyte is fully open source. And if you want to contact me, and please contact me for any question, I'm every day on Twitter, so that's the easiest way. I blog on Dev2 and also on the Yugabyte website. I have my email there. So do not hesitate if you have questions during this talk or later. If you want to try Yugabyte, as I mentioned, it's free. You can run it on Docker. You can run it on Kubernetes, but it's just one possibility. And if you have questions, do not hesitate to contact me. My job is to help users know Yugabyte and use it in the right way. It may look strange to talk about another database at an Oracle event, but now Oracle is not only a database company, it's also a cloud company, and with many databases and with the possibility to run more databases. So of course, you all know the value of the Oracle database, but what if you have applications, some applications that are built to run with Postgres? What if you want high availability, but not with RAC, with a shared nothing where you can scale out without the need for a private network? What if you want to be cloud native? What do we mean by cloud native? It means that you can add multiple nodes to your database, still see it as one database, but with many nodes working and all equal, all writers. So if we look at the databases that we have in the Oracle Cloud, of course, we have the Oracle database with the different flavor, the autonomous fully managed. For example, we have other databases in the database menu, MySQL, of course, NoSQL, which is a scale out and shared nothing, but NoSQL, the database I'm showing here, is fully Postgres compatible and then fully ACID and consistent and SQL. And if you want to run something else than those one, you can still provision VM, but then you have to manage them yourself. For provisioning, a few commercial databases are available on the marketplace, but you can see that you find nowhere in the Oracle Cloud something where you can provision easily Postgres and have it managed. But there is Kubernetes, and the Kubernetes platform on the Oracle Cloud is very interesting, and this is what we will see with this example. Let me explain first why it can be interesting to run on Kubernetes before talking about running a database on Kubernetes. So Kubernetes, when I give this talk to DevOps conferences, everybody knows why they want to use Kubernetes, because they do it for the application for a while, because you want high availability, you want to have your application running on many nodes with many instances of the application with easy scalability, adding nodes, and HA, disaster recovery, because if one node is down, you have other node and you have a load balancer on top of that. And what is really nice with Kubernetes for infrastructure as code, for example, is that it's fully declarative. Adding a node is just changing a number in the number of replicas. So Kubernetes is not new, it's used for applications. And basically, this declaration of your infrastructure, you do it with deployments. And deployments will start pods, so application instances of your application in containers. Those are pods, and those pods can be replicated because you want to scale out with replica sets. Of course, those will run on nodes. For example, I will come back to the demo. I've created a default of 3 nodes cluster so that I can have multiple pods on different nodes. If one fails, I'll still have other ones. And because the application is available on many nodes, you want an easy access to it without knowing where it runs, because a pod can die and be started in another place. So on top of it, you have services which can load balance the access. So you access only through the service, or even with an ingress service where you open a single point from the outside. So this is very short introduction to Kubernetes. It makes sense to run on Kubernetes because it's easy, because it scales, and because it fits on cloud very easily. However, with databases, all those components that you see there are not sufficient, because databases are not like application. They are persistent. You cannot just kill a pod and start another one. You can scale out, you can have high availability, but you need to match the pod with data. And data is shared in the database. You may want to store it at different places, but you will have connection that will read and write data from multiple nodes in transactions. And then you have to, the pods are not completely independent. They must know what is on the other pod. And the component we have seen, the deployment, is not sufficient for that. We have a new component. Sorry, I go at the end first. The stateful sets, which are deployments with a few additional properties like network identity, where a pod will have an IP address even before starting. And you need that because you need to know where the data is, and a map to persistent volumes. So the database will be stored on persistent volumes so that the data is still there if one pod is down. And the pod has a persistent volume claim, which mentions which storage class, for example, the block volume. And a pod will create the volume, and it can die. And if another pod comes, it will replace the other one, take the same identity, and connect to the same volume. So today, it's possible with stateful sets to have stateful applications like databases. This is a bit new because stateful set appeared in 2016 and stable the next year. So this is quite new. Before, it was nearly impossible without some strange tricks to run a database. And I will show you Yugabyte database, which appeared approximately at the same time. If you look at the history of our website, you can see that it started at that time. So we are really talking about the future. It's a new database. It's new to put databases on Kubernetes. It was impossible a few years before. It is possible today. And I think that it will be the way in the future, especially if you have application on Kubernetes, you don't want to maintain the database in another platform. So our example first, so distributed SQL databases. I will focus on Yugabyte because I'm working as a developer advocate for Yugabyte, but there are basically three distributed databases, SQL distributed databases. I mean, distributed databases started with NoSQL. When you give up with transactions, with joins, with foreign keys, then you can scale out to multiple nodes. But then you also have a lot to manage on the application, because what the database doesn't do, you have to do it on the application. And it started with Google, who decided to build kind of on top of NoSQL databases, SQL features, ACID transactions and SQL feature, and that's Google Spanner. For the moment, it's very limited SQL. And it works only on the Google Cloud. And then came CockroachDB, which has taken the same idea, but with more SQL compatibility and working on other platforms than the Google Cloud. And then Yugabyte is going a bit further in the SQL compatibility, because we think that the future is to really have all RDBMS features, because what we have seen in the last years and decades is that the applications need it, rather than adding features one by one on top of distributed storage. We started with a distributed storage and plugged that to Postgres. And then we have all Postgres features plugged into the distributed storage, and then do some optimization, because of course there are some things to change to the query planner, to the executor, for example. But the idea is to have full compatibility. And if you have seen the news recently, so in the past days, Google has announced that they are trying to reach also the Postgres compatibility with Google Spanner, which means that it's like a consensus, like the future is there, having Postgres compatibility on distributed storage. So I will focus on Yugabyte, which is fully open source, same license as Postgres, so you can run all features for free. The commercial offer is just management of it in the cloud or on the platform, but if you want to manage it yourself, it's completely free. And the Postgres compatibility is really high. There are still a few things to optimize and even to add, but the goal is to be fully Postgres compatible. A distributed database has no shared storage, which means that all nodes are equal. You can connect to any node and see it as a database, which is the whole database. So before looking at the installation of Kubernetes, we need to know the components. So in my installation, I will have multiple nodes with persistent volume attached to the stateful set. Let me put that. And we will see two stateful sets. The database with all your data is the T server, tablet server. Tablet is the name of the shard, the partitions of the table that are distributed into the nodes. So basically, the application connects, I go directly to the end of the slide. The application connects to the T server pods, anyone. So it goes through a service that will balance to one or the other. And for the administration, there is also another stateful set that holds the metadata of the cluster. And for the administration, you go there. And I mentioned that we reuse the Postgres code. The Postgres catalog will be in the metadata, so in the master. So of course, in a distributed database, you will have a lot of RPCs between nodes and between T servers and master. And those are the things that are optimized kind of one by one when encountering bottlenecks. And then ready for my demo on the Oracle Cloud. I have started Kubernetes. So for the moment, I will show you what I have started, and I will install a Yugabyte database on it. So if I go back here, everything has been created, which means that I can see my cluster here. A cluster is a set of nodes, actually node pools, which have nodes, and I've defined 3 nodes there. Those nodes are VMs. If I go to compute instances, I will see them here. For the moment, I don't see any persistent volume because I didn't start any stateful sets. Let me go back to the cluster. So for the moment, I have nodes. I have nothing running on it except the control plane. And on Kubernetes cluster, developer service, Kubernetes cluster, my cluster 1. If you want to start, I mentioned that everything is quite easy in the quick start. I just have something to access the cluster, and I will access it from the Cloud Shell because it's just very easy to do that. If I copy paste this, it will define my Kubernetes configuration. I will put that in full screen. Everything is on the top. Below, it's just my my commands that I copy paste here. So it has merged that in my kubectl configuration. kubectl is the way we interact with the cluster. And now I will install Yugabyte. I will install it. There are multiple ways, and all are documented in our website. I will install it with Helm charts. So I add the Yugabyte chart, which is already there. I will, update it, repo update, check the version. We are at version 2.9. Here is the, and now from this chart, I will install the application, which will install the stateful sets, the load balancers, the services, and I will put all that in a namespace YBDemo. So kubectl create namespace YBDemo, and then the installation. Let me run it. So I install. I give a name. In the namespace YBDemo, I install it, and I can set some flags. The only important thing here that I need to mention here is the storage class for the persistent volumes, the OCI BV, block volume, which means that it will start the stateful sets. And when started, I don't know if they have started yet, but when started, it means that in the storage block volume, I should see newly created volumes. I have 3 nodes, and by default, it put 2 mount points on each of them. So those are the volumes created there. So those volumes, if I scale, we will see it, but when I scale, new volumes will be created. But for the moment, my database is stored there. During the creation, I will go back to the slide and explain a few things about what is created. Please interrupt me if there are any questions. I see that there is a chat, there is Q&A, no questions, so let me continue. This is what I've seen at the beginning. So creating the cluster. You have the slides if you want to do the same, showing what is created. So basically, the Helm charts are creating the stateful set. You can also define the stateful set in YAML, for example, but there are kind of customization through the Helm charts. And this is what I've run. By default, the replication factor is 3, which means that my data will be written on 3 places, which is the goal. And if we run on Kubernetes for availability, we want to be able to continue to run if one node is down. If you have replication factor 3, one node can be down, and then everything is still available because there is a quorum. With replication factor 3, if you have 2 nodes down, you don't have the quorum, and then you cannot accept any write and any read because you cannot ensure consistency. If you want to be able to run with 2 nodes down, then you go to replication factor 5. 3 is like high redundancy in ASM if you want to compare. So the stateful sets are declaration. Everything is declared. So with the number of replicas, when we declare stateful sets on Kubernetes, we can mention how we can do updates with rolling upgrades. That's the advantage of running on Kubernetes, because I mentioned at any time you can have 1 node down. If you want to install a new version, then it will add a new pod and remove the other version. And this is how you upgrade without any interruption. Upgrading the Kubernetes version or the OS that is behind or the database. And stateful set just mention what will be run. This is a stateful set for the T server. You have stateful set for the T server and for the master. And of course, the version is a container image. So I've run the 2.9, the slides was before. So you can upgrade with no downtime, and that's really cool. I go fast on the different settings. The services. So you need services because you can connect to any node. And here I'm talking about pods, the nodes of the databases. You can connect to any, but you don't want to give a big list to the application, especially because it's very dynamic. You can add nodes, have nodes removes. So you want a service that is like a load balancer, but we even use an headless service so that it's not a proxy, it's just an entry in the DNS that will send you to the right node, to the one of the available nodes. And multiple ports are displayed there. I will show you the Postgres because the big value of YugabyteDB is that it is Postgres compatible, but it's also multi-API, which means that we have a Postgres endpoint and we have also a Cassandra endpoint, which can make sense if you are doing IoT or large ingest of data, because the API is more efficient with that. With the Cassandra API, you cannot join, but you still have transactions because the storage engine is transactional. But the drivers are better for high load. So you have the choice. About the storage, I will go quickly through it. You don't need a shared storage. That's the goal. All the distribution, the replication is done by the database. So you don't need a shared NFS, for example. And the storage can be on persistent volume, which is probably what you want for production. But if you think you can rely on having always the quorum of nodes up, maybe you want better performance, lower latency with ephemeral storage. But of course, if all nodes are done, then you lost data. So that's your choice. Persistent volume, this is how they are declared within the stateful set. When you see read-write once, it's not that you can read or write only once. It's just that it is mounted in read-write only once because it is not shared. Each pod will have its persistent volume. And another property of Kubernetes, you can manage a lot of things in Kubernetes, and it's just declarative. You don't have to code for that, except YAML. This is very important, anti-affinity, because you have many worker nodes, so VMs, and you have many pods, the database nodes. And obviously, you don't want all of them running on the same server because you want availability if a node is down. So with the maximum Y in the anti-affinity, Kubernetes will put pods far enough to be resilient. And you can choose preferred or required, I think. So if it's required and there are not enough available VMs, that you cannot scale. So again, you decide it, and it's declarative. The Helm chart is a good way to start, but then you can change the stateful set, of course. Headless services, I mentioned, you do not need a proxy. You do not need a load balancer. You can, but you do not need just an entry, a DNS entry. The application knows only one endpoint, one IP address and port, and then we'll go to one available node. Any node is available to take reads and writes. And we can see external IPs, but I will go back to the demo because I think that now everything has been created. And yeah, the creation just mentioned how to connect. With kubectl, you can check what is there. So the two stateful sets, the master and the server with 3 pods for each. Of course, replication factor 3 needs at least 3 of them. If I query the pods, I can see the 3 masters, the 3 servers, and their IP in the network. And the services, because I will connect to the services, the master has a service, and we will open the console from the master, but the Postgres endpoint, which is by default the port 5433 here, is in this case a load balancer, and with an external IP, And I have just a few command line shortcuts to get things with get services, and just to extract the IP and port so that I will connect to it. This is the master. So this is the console. And from the Yugabyte console, I can see that I have a cluster. This is a universe. We call a cluster a universe because it's quite larger than a cluster. You can have nodes in different countries if you want. So for the master, we have one leader and followers. This is how it works. Everything is partitioned. So you have the master and the tables will be partitioned. And I have a leader partition in a node. So read and write go to the leader. But if this node is down, a follower can be quickly elected as the new leader and fully consistent with no data loss, because writes ensures that it is written to the quorum, the leader plus one follower in this case. And the tablet servers, I can see my 3 tablet servers. For the moment, I have no data. So I'm taking the Postgres endpoint here, and we don't need another driver. We just connect with the Postgres driver because we are fully compatible. It's not just the same syntax. It's the same protocol. It's even the same code that we reuse. We have a fork of Postgres with some additions to plug the distributed storage. I will connect with Python just because it's easy to install there. And I'm getting the environment variable for Postgres to connect to the load balancer. And then I need only one endpoint and everything works. Here I have, so it's in Python. Let me just explain quickly what I'm doing. I connect, so everything will connect with the same endpoint, the load balancer. I'm doing some auto commits there, some pandas to display things, not very important. I will create a table. Just additional syntax we have that you don't have in Postgres. We can decide in how many shards, partitions, the table will be splitted. Of course, it can be also done automatically, but we can control it if we want. I'm doing explicitly many tablets here because I will have a small table, but I want to see multiple tablets. I insert some data, just only one row. Let's do things quite small. This is my row, and I can query it. And now I will query on which server I am. So I'm connected through the load balancer, but I went to a node, and this is the IP address of the node where I am. Just using the Postgres functions, nothing more. That if you know Postgres, is the same. I connect again. and I will check on which server I am. It's a different IP. I'm on a different node. Each time I can go to one of the three database nodes that I have there, pods. And if I query my table, of course, I see the same thing. My vision is one endpoint and one database, but physically, it's multiple nodes collaborating to exchange and maintain data in a resilient way and consistent way. So nothing, when I do this presentation to developers and DevOps, it's more important for database people. Of course, they expect that reconnecting to a different node, we can see the same data. More interesting for people coming from databases, the scale up and scale down. So first, I will run some activity. And you don't have to read all that if you don't like Python. I have just a loop doing inserts in this table. And I will run that other loop. So it connects still with the same endpoint. So it's connected to a server. And you can see every 100 inserts, I reconnect. And then you can see that each time it's connected to a different server, but the number of lines is added to it. So that's just a loop. And what I want to show, let me go back to the slides just to be in line with the slides. So what I will show, you have screenshots in the slides if you want to look at it later. So this is running. Now I will scale out. So this is running in 3 nodes. Let me check the console. Of course, we can see if I refresh that it is running. I see some read operations and write operation on each node because I have people connected to nodes, to a random node. And even when connected to a node, when I insert, I may insert in a table tablet that is on one node and maintain an index that is on another node. So all nodes are working together in collaboration to keep our database, to maintain our database state. So this is running. And now I want to show you, let's say that I want to scale up, add some nodes. Why? Because I want more performance, or why? Because I want to add a node in another availability domain or even a region. And then, so I put that in the background just to run the things there, but I will put it in the foreground to show you that you do that online, of course. I'm still connected. And here is kubectl scale. I just mentioned the stateful set, the T server. Instead of 3 replicas, I want 6 of them. And I forgot to add nodes. I still have 3 nodes, so that's not okay. I will have to add some nodes, and I should have done that before, but we will have time to do everything. Let me go to the cluster. OKE, Oracle Kubernetes engine, maybe the call. So the cluster is there. I go to the node pools. And this pool, which has 3 workers, I will set 6 of them. So for the moment, in what I've done, I told to Kubernetes that I wanted to scale to more than 1 server. So you can see 6 of them. And now I have added new nodes. And then because of the anti-affinity law, those new pods will go to different servers. Let me put back this running so it's still connected. And if I go to the console here, the database has seen that there are more database nodes and will rebalance data between them. I refreshed. So for the moment, I see 3 additional servers. I have still only 3 of them taking reads and writes. because it has to take time to rebalance everything. And I will go to the slide. Oh, we can see that one more is active there. The T-server 4 has started to take reads and writes, less than the other, but if I refresh, it will slowly come to that. First, it has to rebalance the tablets and then serve them. Do you have any questions? I'm looking to questions and answer, looking at the chat, nothing. Any feedback, comments, just tell me. So in the slide, you have the screenshot of what I've done there. And then I will show a node failure. We will kill a node. And then I will explain a few more things. So first, let's check that all nodes are working there. Okay, you see the load is slowly distributing over all the different nodes. And now I will kill one of them. I will do that softly. So the application is still running. Full high availability there. I will just put the application in the background, run the scale to 5 replicates. So this is a soft kill, just mentioning, saying to Kubernetes that I want one less pod, but because I add data and connections to it, it will wait, rebalance, and we will see it. So Kubernetes has killed the pod. And the only thing I see for the moment is that it doesn't answer to the heartbeat for 20 seconds. Of course, there is a parameter. The default is that for transient failures, you just wait to see if it comes back. Because if it comes back, it will come back with the same persistent volume and you don't have to rebalance anything. But after 60 seconds, we will consider this node as dead and then rebalance everything. But of course, something I should have mentioned before, this node had some tablets with their leader on this node. There were a quick election of a follower in another node to become the leader. I will show that just after, but let's refresh. We have passed the 60 seconds. This is considered as dead, and I have a cluster with 5 of them. I see there is a question. I will come to the question later. Just saying that I have killed T-server 5 there. If I look at my table, I can see the different tablets. So the shards, the table is partitioned, but at storage level to be stored everywhere. And obviously, I don't have any leader in T-server 5. And there are still some followers there that will be moved to other nodes. But during the failure, every work that was done on the other nodes still continue exactly the same. And the work that had to go to the leader in the node that failed just had to wait a few seconds for the leader election with the Raft protocol. And my application, of course, is still running. I'm still connecting to many nodes. And it doesn't try to connect to the dead node just because the load balancer knows that it is down. Let me look at the questions. Do you need to increase node count before increasing tablet servers every time? In this case, because I have, let me go to the slide to explain it. Again, it's your choice. When you defined the replicates in the stateful set, here, where it is no, sorry, it's in the anti-affinity rule. There, you have the choice preferred or required. If it's preferred, and you have 6 pods on only 3 workers, if it's preferred and you have enough resources, then you can have 2 pods in the same worker. In production, you will probably put required, which means that adding a new database node means that you have a pod in a different worker to be sure that you have availability. So the answer there is you have the choice to mention that you want nodes. But then if you look at the status, Kubernetes will tell you the reason why it cannot start a new pod. Can be not enough resources, not enough workers, and all that. Okay, if I go back, so here we have a 5-node cluster now with everything distributed there. And I come back to the slide. So this is answered. Tell me if you have another question. What I wanted to show here is, but I will do that quickly on the slides because we have 5 minutes and probably better to take questions. You need to know what is managed automatically by what. Kubernetes, for example, will manage it automatically if a pod fails. So one pod, one database node fails, Kubernetes starts another one. If it were a deployment, a replica set, it could have a different IP address, different storage, everything. But because it's a stateful set, it will restart the pod, attaching to the same persistent volume and with the same IP address. So for the database, it will be kind of transparent. Probably it was not available for a few seconds, and then new leaders have been elected to continue to work. But if a pod fails, it's Kubernetes' job to start another one. If a node fails, then you have to add another one. And of course, there are features, there are operators which can do that automatically. But the idea is that you decide the number of nodes that you want. If you are in the cloud, you will probably add at least 1 worker in each availability domain in a region. But you can decide also to run on multiple regions. You can also run multiple clouds with Yugabyte. Maybe not with Kubernetes cluster, but Yugabyte having nodes in different cloud providers. And what the database does is automating resharding. So if one worker is down and with its storage, then you have to come with a new server, but then Yugabyte will detect it's there, it started, and will reshard as we have seen there. Of course, a big advantage is running upgrades. Application is still up when you are upgrading one node after another, and the database handles also the new version. So there is a version of the catalog, and that is backward compatible. Backup and restored from Yugabyte, you can do distributed snapshots and backups. And you can restore that to another cluster, and that's manual. I have here a slide with a lot of text just to try to answer a question. I'm not saying that you need a distributed database like Yugabyte to run a database on Kubernetes. As long as you have stateful sets, you can run a database on Kubernetes because you have persistent volume and network identity. However, if you use a monolith database like Postgres or Oracle, you will have only one node that can take writes. Of course, Oracle Rack is different, but it's not yet ready to run on Kubernetes, in my opinion, because there is shared storage in that. But the idea is that you can run a monolith database, but then you have only one writer, and then you cannot scale out. So what people do to scale out is sharding the database. So instead of storing your application data in one database, You shard it, for example, on the hash value of the customer ID, and you put data distributed in many databases. And then each database has its replication for high availability and disaster recovery. This is possible, but this is very complex because each one must be distributed and you have to manage that. It takes a lot of resources, and in the cloud, resources is a cost, and you have a lot of nodes that are there just as a standby that you cannot use except for read-only. So the big difference with that distributed databases is that all nodes are identical. You can connect to any of one, and the database is managing the balancing of data in different nodes and the replication of it. It's still called sharding, but you shard at the lower level in the storage. A part of the table is sharded. It's not like having multiple databases. From the application, you have only one database, and that makes things a lot simpler. My conclusion on this, and then we will see if we have time for questions. My conclusion is first to tell you that it is possible today to run a database on Kubernetes. 5 years ago, I would have said the opposite. It's not possible because stateful sets were not there and distributed database were not ready for that. Not for SQL. For NoSQL, yes, but not for SQL. Today, it is possible to have a Postgres database that is active on multiple nodes. And automation, of course, you want things easy to manage. That's the goal of Kubernetes. And then the same for the database. If a node is down, Kubernetes creates the pods elsewhere, then you expect the database to put data on it. And then the reason to distribute resilience, high availability, if you are in different availability domains, but also geo-distribution. In Yugabyte, you have also some additional features still in the open source version of it, where you can tag some data to specific countries. For example, if for legal reason, you want to manage one database, but with data from US people in a US data center and something like that. If you have questions about it, you have my email, you have my Twitter, and you will find me easily on Google, LinkedIn, anything. And also because it's open source, you can test it for free. You can even look at the source code. You can even contribute to the source code. That's the idea, exactly same as Postgres. So if you want to use or contribute, GitHub is there, and developers like to see stars on GitHub. So if you go there, do not hesitate to star us. And we have a Slack channel for users where we help users to with their questions, but also where we have users who contribute. That's the goal of being open source. Creating a new database today is hard work, even whatever the size of the company. And the idea is that when it is full open source, you have people contributing to it and making the database more powerful. Do you have any questions? Looking at the Q&A, at the chat. In the meantime, I can open a website, YugabyteDB. If you look at the documentation, it's, in my opinion, very easy to start if we look at the documentation. And also feedbacks are very good. I'm a developer advocate, so my goal is to listen to users, know what they need, what we can change, and talk also with our developers. So YugabyteDB Core is the open source database. And if you want to start, you have the choice how to install it. And Kubernetes is just one possibility, but you can run it on Docker, on Linux, on anything. That's the goal.